The weapon in question was the Republic P-47 Thunderbolt, armed with 8 Browning M2 50 caliber machine guns, each firing 50 BMG, 12.7 mm ammunition. Before combat deployment, the P-47 was widely criticized within Allied planning circles, not for its firepower, but for its size, weight, and perceived inefficiency compared to existing fighter designs. At the time of its introduction, prevailing fighter doctrine favored lighter, more maneuverable aircraft. Aircraft such as the Supermarine Spitfire and Messerschmitt Bf-109 emphasized climb rate, turning ability, and low-altitude agility. The P-47 contradicted these priorities. The P-47 had an empty weight exceeding 9,900 pounds and a loaded weight over 14,000 pounds, making it one of the heaviest single-engine fighters of the war. Critics argued that this mass would make it inferior in dogfights and overly vulnerable in combat against lighter enemy aircraft. Another point of criticism was its radial engine configuration. The P-47 used the Pratt & Whitney R2800 Double Wasp, an 18-cylinder air-cooled radial engine. Many planners believed inline liquid-cooled engines offered a smaller frontal profile and better aerodynamic performance. The large radial engine was viewed as increasing drag and visibility. Range was also a major concern. Early P-47 variants had limited operational radius, which restricted escort capability. In 1942 and early 1943, this limitation made the aircraft appear unsuitable for long-range bomber escort missions over occupied Europe, one of the primary needs of Allied air strategy. Critics also questioned the aircraft's climb performance. Initial test data showed slower climb rates compared to contemporary fighters. This raised concerns about the P-47's ability to intercept enemy aircraft at altitude or disengage from combat when necessary. The aircraft's armament, while heavy, was also seen as inefficient by some planners. The 8 50 caliber machine guns added significant weight and required large quantities of ammunition. A standard load consisted of 3,400 rounds total, roughly 425 rounds per gun. Analysts argued that this weight reduced performance and that cannon-armed fighters could achieve similar effects with fewer rounds. Operational doctrine at the time emphasized precision and efficiency. The idea of saturating targets with machine gun fire was not universally accepted as superior to fewer, heavier caliber weapons. This contributed to skepticism about the P-47's design philosophy. Maintenance complexity added to doubts. The turbo supercharger system, essential for high-altitude performance, required extensive ducting and added mechanical complexity. Early maintenance reports noted increased workload and logistical demands compared to simpler fighter designs. Because of these factors, early deployment plans treated the P-47 conservatively. Initial assignments prioritized high-altitude escort and interception roles, where its turbo-supercharged engine could theoretically compensate for weight and size. Even then, expectations were limited. Enemy assessments mirrored these doubts. German pilots encountering the P-47 for the first time often noted its size and assumed it was less maneuverable and easier to destroy. Intelligence summaries initially categorized it as a heavy, cumbersome fighter unlikely to pose a serious threat in close combat. What these evaluations failed to account for were the aircraft's structural strength, ballistic output, and combat survivability under fire. The P-47's airframe was built around durability. Its large size allowed for extensive armor protection, redundant systems, and fuel tank placement that reduced vulnerability. The radial engine, contrary to early assumptions, proved more resistant to combat damage than liquid-cooled inline engines, which were vulnerable to coolant loss from small-caliber hits. The 50 BMG ammunition fired by the Browning M2 had proven ballistic effectiveness. At typical combat ranges, it delivered sufficient penetration to damage aircraft structures, engines, and control systems. When delivered in volume, the combined fire of 8 guns created a dense projectile stream that increased hit probability during high-speed engagements. These characteristics were not theoretical advantages, they were measurable and would soon be demonstrated under combat conditions. The dismissal of the P-47 was therefore not based on ignorance, but on doctrinal assumptions that prioritized agility over survivability and efficiency over volume of fire. Those assumptions had not yet been tested against the realities of sustained air combat over Europe. That test would come quickly, and when it did, the gap between pre-war evaluation and combat performance became impossible to ignore. The Republic P-47 Thunderbolt entered sustained combat service with United States Army Air Force's fighter groups operating from the United Kingdom in 1943, primarily as part of the 8th Air Force. Its initial employment focused on high-altitude escort and air superiority missions over occupied Europe, where combat conditions immediately tested the assumptions that had shaped earlier criticism. From the outset, mission reports and after-action records emphasized measurable performance rather than subjective impressions, and those records showed a consistent pattern. At operating altitudes between roughly 25 and 30,000 feet, the P-47's Pratt & Whitney R2800 double WASP engine, combined with its exhaust-driven turbo supercharger, allowed the aircraft to retain power, where many contemporary fighters experienced noticeable performance loss. In level flight at altitude, the Thunderbolt matched or exceeded the speed of German fighters it encountered, particularly the Messerschmitt Bf 109G and Focke-Wulf FW 190A. While its sustained turning performance remained inferior, this limitation was mitigated by doctrine that emphasized energy retention rather than maneuver combat. Combat reports consistently document the same engagement pattern. P-47 pilots initiated attacks from altitude, converted height into speed, fired during short, high-closure passes, and disengaged using the aircraft's superior dive performance. Structural data confirmed that the airframe could tolerate dive speeds that exceeded those safely achievable by many German fighters, allowing Thunderbolts to exit engagements without structural failure. This capability reduced losses during disengagement, a phase where lighter aircraft were often vulnerable. The effectiveness of the P-47's armament was documented quantitatively rather than anecdotally. The aircraft carried 8 Browning M2 50 caliber machine guns firing 50 BMG ammunition, with a combined rate of fire exceeding 6,000 rounds per minute. During a typical firing pass lasting 1 to 2 seconds, more than 200 projectiles were delivered into the target area. Combat records repeatedly emphasize that destruction resulted from projectile density rather than reliance on single-hit lethality. At typical engagement ranges, armor-piercing and armor-piercing incendiary rounds penetrated aircraft structures, engines, and control systems, while incendiary effects increased the likelihood of fire following penetration. Damage assessments conducted after combat sorties provide verifiable evidence of survivability. P-47s routinely returned to base with extensive battle damage, including hits from 20mm cannon shells. Aircraft were recorded landing safely despite damage to wings, tail surfaces, and control systems. The radial engine configuration proved resistant to combat damage as it did not rely on a liquid cooling system vulnerable to immediate failure from small caliber hits. This translated directly into lower loss rates compared to earlier projections. Enemy reaction was documented indirectly through changes in German tactics. Luftwaffe pilots increasingly avoided prolonged engagements with P-47 formations at altitude and shifted toward attacks that minimized exposure to concentrated defensive fire. Intelligence summaries noted that head-on attacks against bomber formations escorted by Thunderbolts resulted in higher German losses due to the density of machine gun fire encountered during closing passes. Maintenance and operational records further reinforced these findings. Despite early concerns about the complexity of the turbo supercharger system, mission availability rates improved as ground crews gained experience. The aircraft's robust construction reduced attrition from non-combat causes, and damaged airframes were often repairable, returning to service rather than being written off. The cumulative data from 1943 established a clear record. The P-47 did not succeed by conforming to existing fighter doctrine. It succeeded because its actual combat environment rewarded survivability, energy retention, and concentrated firepower over low-speed maneuverability. The conditions of high-altitude escort combat over Europe favored an aircraft that could absorb damage, deliver a short but dense burst of fire, and disengage safely. These outcomes were not speculative. They were recorded in mission summaries, loss statistics, and maintenance logs. By the end of its first sustained combat period, the Thunderbolt's performance forced a reassessment of earlier judgments. The aircraft that had been criticized as too heavy and inefficient was now producing verifiable results under combat conditions. The dismissal of the P-47. Desechilor de P-47 had been based on assumptions about how air combat should be fought. Combat demonstrated how it was actually fought. Once the P-47 Thunderbolt began appearing regularly over occupied Europe, German air defense faced a set of constraints that limited its ability to counter the aircraft effectively. These limitations were not theoretical. They were recorded in operational outcomes, loss patterns, and tactical adjustments observed over time. The primary constraint was energy dominance at altitude. The P-47 operated most effectively above 25,000 feet, a regime where its turbo-supercharged radial engine retained power more consistently than many German fighters. While aircraft such as the Bf-109G and Fw-190A could reach similar altitudes, their sustained performance there was more sensitive to engine strain and fuel consumption. This meant German pilots often entered engagements already operating near the limits of their aircraft's optimal performance envelope, while P-47 pilots retained excess energy for attack and disengagement. German countertactics relied heavily on interception timing. Fighters were expected to climb rapidly, attack bomber formations or escorts, and disengage before Allied numerical advantage became decisive. The P-47 disrupted this sequence. Its speed at altitude reduced the time window available for interception, and its dive performance allowed it to pursue briefly and then disengage without structural risk. Combat records show that German pilots frequently broke contact rather than risk extended engagement, limiting their ability to inflict losses. Firepower density further constrained enemy response. The 8 Browning M2 machine guns firing 50 BMG ammunition produced a volume of fire that altered engagement geometry. German pilots could not safely close to the ranges required for effective cannon fire without exposure to concentrated machine gun streams during the approach. Head-on attacks, previously a favored method against bomber formations, became increasingly costly when Thunderbolts were present. Loss reports indicate that German fighters attempting frontal passes suffered disproportionate damage before completing their attack runs. Structural survivability also reduced the effectiveness of German weapons. Luftwaffe fighters were armed primarily with 20 mm and later 30 mm cannon designed to destroy bombers with limited hits. Against the P-47, these weapons were less decisive than expected. The Thunderbolt's rugged airframe, armored cockpit, and absence of a liquid cooling system allowed it to absorb damage that would have disabled or destroyed lighter fighters. Maintenance records confirm that aircraft struck by cannon fire frequently returned to base and were repaired, denying the enemy permanent attrition. Another limiting factor was tactical predictability under pressure. As Allied fighter numbers increased, German units were forced to operate defensively, choosing engagements carefully and avoiding prolonged combat. This reduced flexibility made it difficult to adapt tactics specifically to counter the P-47. Instead of developing tailored responses, German pilots increasingly avoided encounters when Thunderbolts held altitude advantage. Operational constraints further compounded the problem. Fuel shortages reduced training hours and limited tactical experimentation. Replacement pilots entered combat with fewer flight hours and less experience operating at high altitude. These factors reduced the effectiveness of complex interception tactics that might have mitigated the P-47's advantages. Enemy intelligence assessments initially underestimated the Thunderbolt's durability and sustained combat effectiveness. Adjustments came only after repeated encounters produced consistent results. By that point, German fighter forces were already under strain from attrition and could not afford the losses required to test new approaches extensively. Ground-based air defenses also struggled to counter the aircraft effectively during escort missions. The P-47's altitude profile placed it beyond the optimal engagement envelope of much light flak, while its speed reduced exposure time. Heavy flak remained a threat, but it was designed to disrupt bomber formations rather than single-engine fighters maneuvering independently. As a result, German countermeasures shifted toward avoidance rather than engagement. This shift is visible in engagement frequency, attack patterns, and the increasing reliance on brief, opportunistic strikes rather than sustained combat. These adaptations reduced German losses in the short term but ceded control of the air to Allied forces over time. The inability to counter the P-47 effectively was not due to a single failing. It emerged from the interaction of altitude performance, firepower density, survivability, and operational constraints. Each factor alone was manageable. Together, they imposed limits that German air defenses could not overcome consistently. Combat outcomes reflected this reality. The Thunderbolt did not eliminate German fighters on its own, but it reduced their freedom of action. It forced changes in tactics, shortened engagement windows, and increased the cost of every attack attempt. These effects accumulated over time, contributing to the broader erosion of German air capability. By the time countermeasures were adjusted, the conditions that might have allowed effective adaptation, fuel availability, pilot experience, and numerical balance were already deteriorating. The result was a sustained mismatch between what German defenses needed to do to counter the P-47 and what they were actually able to do. This mismatch explains why early dismissal gave way to operational respect. The Thunderbolt succeeded not by eliminating enemy capability outright, but by constraining it systematically, until effective opposition became increasingly difficult to sustain. As combat data accumulated through 1943 and into 1944, the employment of the P-47 Thunderbolt began to change in ways that reflected measured outcomes rather than theoretical debate. This shift was not driven by opinion or preference, but by recorded mission results, loss rates, and comparative effectiveness across roles. Early in its service, the P-47 had been assigned primarily to high-altitude escort duties because that role aligned most closely with its turbo-supercharged performance characteristics. However, operational records soon demonstrated that the aircraft's strengths extended beyond its initial mission profile. The same characteristics that made it survivable in air-to-air combat, structural strength, redundant systems, and resistance to damage, also made it suitable for sustained operations in environments with heavy ground fire. By late 1943, units began employing the P-47 increasingly in fighter bomber and ground attack roles based on measurable survivability data. Mission reports showed that Thunderbolts could absorb small caliber and medium caliber anti-aircraft fire at rates that would have resulted in higher loss levels for lighter fighters. Aircraft returned with extensive flak damage, yet remained operational. Maintenance logs confirmed that a high proportion of damaged P-47s were repairable, preserving force strength over time. Armament data reinforced this shift. The 8 Browning M2 machine guns firing 50 BMG ammunition proved effective not only against aircraft, but also against ground targets. Armor-piercing and incendiary rounds penetrated lightly armored vehicles, locomotives, and supply convoys. Strafing reports documented destruction of trucks, rail stock, and artillery positions. The volume of fire delivered during low-level passes increased hit probability against dispersed targets, compensating for the brief exposure windows imposed by ground fire. These results led to formal changes in tasking. The P-47 was increasingly assigned to interdiction missions, targeting transportation networks, fuel depots, and troop movements. This employment was driven by operational necessity and validated by results. Interdiction sorties reduced enemy mobility and disrupted logistics, effects that were recorded through follow-up reconnaissance and battlefield reports. At the doctrinal level, this represented a shift in how fighter aircraft were valued. Pre-war and early war doctrine emphasized air-to-air maneuverability as the primary measure of fighter effectiveness. Combat data from the Thunderbolt demonstrated that survivability, payload capacity, and firepower could be equally decisive when air superiority had been established. The transition was reflected in production and deployment decisions. Rather than reducing P-47 output in favor of lighter fighters, the aircraft continued to be produced in large numbers through 1944. Successive variants incorporated refinements based on combat feedback, including improved dive recovery systems and increased external payload capacity. These changes were incremental and data-driven, not conceptual redesigns. Enemy response further reinforced doctrinal change. As German fighter activity declined and ground defenses became the primary threat, aircraft capable of surviving repeated exposure to flak became operationally valuable. Loss statistics showed that Thunderbolt units maintained lower attrition rates relative to sortie count and ground attack roles compared to lighter fighters operating in similar conditions. By mid-1944, the P-47 was no longer treated as a specialized high-altitude interceptor. It had become a multi-role platform integrated into broader operational planning. Its employment reflected a recognition that air power effectiveness depended not only on defeating enemy fighters, but on sustaining pressure against enemy systems over time. The doctrinal shift was therefore not ideological. It was empirical. Commanders adjusted roles based on what aircraft could demonstrably survive, deliver, and sustain under combat conditions. The Thunderbolt's earlier dismissal faded as its operational record expanded across mission types. Combat did not change the aircraft. Combat changed how it was used. By the end of its primary combat employment in Europe, the operational record of the P-47 Thunderbolt no longer required interpretation. The accumulated data was sufficient on its own. Mission statistics, loss ratios, damage assessments, and post-operation analysis converged on a consistent set of conclusions about what the aircraft actually contributed under combat conditions. The first conclusion was survivability. Loss records showed that the P-47 absorbed damage at a rate that exceeded pre-deployment expectations, while maintaining a lower probability of permanent loss compared to lighter fighters operating in similar roles. Aircraft frequently returned with heavy structural damage, engine hits, and control impairment that would have resulted in total loss in more lightly built designs. Repair logs confirmed that a large proportion of damaged Thunderbolts were returned to service, preserving combat strength over time, rather than consuming replacement capacity. The second conclusion concerned firepower effectiveness. The 8 Browning M250 caliber machine guns firing 50 BMG ammunition produced results that scaled with engagement conditions rather than relying on precision or prolonged exposure. In air-to-air combat, concentrated projectile density during short firing windows produced consistent structural and system damage to enemy aircraft. In ground attack roles, the same ammunition penetrated lightly armored vehicles, locomotives, fuel transports, and artillery positions. These effects were verified through reconnaissance, battlefield reports, and destruction counts rather than pilot testimony alone. The third conclusion was operational flexibility. The P-47's performance envelope allowed it to transition between high-altitude escort, air superiority, interdiction, and close air support without requiring fundamental changes in doctrine or infrastructure. This reduced the need to specialize aircraft for narrow roles and simplified force allocation. Units could be retasked rapidly based on operational demand, an advantage that became increasingly important as Allied operations accelerated across multiple fronts. Another measurable outcome was attrition efficiency. When sortie counts were compared against aircraft losses, Thunderbolt units demonstrated favorable ratios in sustained operations. This did not imply immunity from losses, but it showed that the aircraft imposed lower replacement and training burdens relative to the number of missions flown. Over time, this translated into greater continuity of experienced pilots and maintainers within operational units. Enemy adaptation further reinforced these findings. German tactical behavior shifted in response to Thunderbolt deployment, with reduced willingness to engage escorted bomber formations aggressively and increased reliance on avoidance or brief interception windows. On the ground, dispersion of transport and reliance on movement at night reflected the impact of sustained interdiction pressure. These adaptations were observable consequences of repeated exposure, not isolated reactions. The data also exposed the limitations of earlier evaluation criteria. Pre-war and early war assessments had emphasized maneuverability, climb rate, and aerodynamic efficiency in isolation. Combat demonstrated that these metrics did not fully capture battlefield effectiveness in an environment dominated by high speeds, short engagement times, dense firepower, and persistent exposure to anti-aircraft fire. Survivability, maintainability, and the ability to sustain repeated missions emerged as equally decisive factors. Importantly, the record did not suggest that the P-47 was universally superior in all contexts. It remained less effective in sustained low-speed maneuver combat and required altitude to maximize its advantages. However, within the operational conditions that actually existed over Europe from 1943 onward, its strengths aligned closely with mission demands. By the time production shifted and newer aircraft assumed greater prominence, the Thunderbolt's role had already been secured by evidence rather than argument. It had proven that a weapon dismissed for violating prevailing assumptions could succeed by exploiting realities those assumptions failed to measure. The data did not show a dramatic transformation. It showed consistency. Consistency across missions. Consistency across theaters. Consistency between expectation and outcome, once combat replaced theory. The weapon was not vindicated by belief or reputation. It was vindicated by records. By the time large-scale operations in Europe reached their final phase, the evaluation of the P-47 Thunderbolt no longer depended on comparison, advocacy, or debate. Its effectiveness had been established through repeated, documented use under sustained combat conditions. The aircraft entered service burdened by assumptions rooted in pre-war fighter doctrine. Those assumptions prioritized low-weight designs, tight turning performance, and theoretical efficiency under controlled conditions. Combat demonstrated that the environment over Europe did not reward those priorities consistently. Instead, it rewarded aircraft that could survive damage, deliver concentrated firepower in short engagement windows, and return to service repeatedly without excessive attrition. The Thunderbolt met those requirements in measurable ways. Its radial engine configuration reduced vulnerability to single-point failure. Its airframe tolerated high-speed dives and absorbed combat damage without immediate loss. Its 8 Browning M2 machine guns firing 50 BMG ammunition produced effects that scaled with volume rather than precision, aligning with the realities of high-speed aerial combat and low-level ground attack. These were not abstract advantages. They appeared repeatedly in mission summaries, maintenance records, and loss statistics. The shift in how the aircraft was employed reflected those facts. Initial use as a high-altitude escort expanded into fighter-bomber and interdiction roles not because doctrine demanded it, but because results justified it. The aircraft remained operational under conditions that imposed unsustainable losses on lighter platforms. Its ability to fly, fight, take damage, and fly again mattered more than theoretical performance margins that could not be exploited consistently in combat. Enemy adaptation further validated these outcomes. Changes in German interception tactics, reduced engagement duration, and increased avoidance behavior reflected the constraints imposed by Thunderbolt formations. On the ground, disruption of transport and logistics confirmed the cumulative effect of sustained interdiction. These were observable consequences, not inferred ones. What combat ultimately confirmed was not that the P-47 was misunderstood, but that the criteria used to judge it before combat were incomplete. The aircraft did not succeed by overturning doctrine through argument. It did so by operating in conditions doctrine had failed to model accurately. The dismissal of the Thunderbolt occurred because planners evaluated it against expectations that no longer matched the battlefield. Combat corrected that mismatch. Once corrected, the role of the aircraft became self-evident. The weapon was not proven by belief. It was proven by use. It was not validated by theory. It was validated by results. That is why it remained in service, expanded in role, and left a record defined not by controversy, but by measurable performance under pressure. This is how weapons are judged in war, not by design intent, but by what survives contact with reality. If you want fact-driven breakdowns of World War II weapons, battles, and systems based on records, performance data, and operational outcomes, subscribe to WW2 Battles. The next video examines how German pilots reacted when they first encountered this aircraft in combat and why their tactics changed afterward.